GMAT all day.
For this last divisibility question, I would like to make my closing argument for why divisibility truly is the most valuable topic to know for the GMAT. And I called this a word translation question. It's really just divisibility combined with other topics. I could have called it combined or something, but word translations is good enough. And really what I want to show here is how if you just know your divisibility rules and your divisibility patterns, how far you can translate or simplify a question, how you can take a super long and complicated question and turn it into something that says something like, what is X? Something that is completely removed from what you initially started with. And that is the goal. Now, I don't want you to think that you need to break down and simplify this question as much as I do here. Certainly, if you can partially simplify it and then test numbers or something to get you the rest of the way, that is a totally valid way of approaching it. I don't want you to think that you have to approach this one way and only one way. And if you don't know that way, then you're doing it wrong. That is certainly the wrong mindset to have on the GMAT. You want to have multiple ways of doing something, and then you can just choose what works for you. So this question says, at Bayside High School, a 3-student prom committee must be comprised of exactly 1 sophomore, 1 junior, and 1 senior. Bayside's junior class contains 1 more student than its sophomore class, and Bayside's senior class contains 1 more student than its junior class. If Bayside's sophomore class contains n students, is the total number of possible prom committees a multiple of 12? So, to start, let's just write out what our committee looks like. We have this prom committee with 3 students on it, and one of these slots must be a sophomore, 1 must be a junior, 1 must be a senior. The stupid freshmen do not get to be involved in planning the prom. And what we know is we have n sophomore students, and then we have n plus 1 junior students, and then we got n plus 2 senior students. That is total. And so in other words, for this slot here, I have n students who I can choose from in my sophomore slot. I have n plus 1 students who I can choose from to be in my junior slot. I have n plus 2 students who I can choose from to be in my senior class. So this sort of sounds like a combination question, but we're going to turn it into more of a divisibility question. And so I want to find the total possible prom committees. What am I really saying? So if I have n options for who I can choose for my sophomore, and I have n plus 1 options for who I can choose for my junior, then I have n times n plus 1 options for who I can choose for my sophomore/junior spot. And then any of those n times n plus 1 sophomore junior combinations can be paired with n plus 2 seniors, give me n times n plus 1 times n plus 2 sophomore, junior, senior prom committees. And so we want to know, is the total number of prom committees a multiple of 2? A multiple of 12, I should say. So is n times n plus 1 times n plus 2 a multiple of 12? And so we go back to a few questions ago. I think we said, how can you think of that? Is if something is divisible by 12, same saying, is it divisible by 6 and 2? Is it divisible by 4 and 3? Or if you want to fully break things down into their prime factors, is the total number of possible prom committees a multiple of 2 2s and a 3? Does it contain 2 2s and a 3? So within this n times n plus 1 times n plus 2, I am looking for 2 2s and a 3. So to start, I would say, let's focus on our 2s, because what does it mean when I say, does this contain 2 2s? Well, to contain a 2, that just means we need to have an even number. Any even number is going to contain a 2. That is the definition of an even number. An even number is a multiple of 2. And if I see these are my total possible prom committees, well, I can also say that there's only 2 possibilities for this value here, n. N is either going to be even or it's going to be odd. Remember, n is the number of people in my sophomore class, so it cannot be a decimal. I either have an even number of people in my sophomore class or you have an odd number of people in your sophomore class. Then, because this here is a consecutive set, and I am always on the lookout for consecutive sets because they have special properties which are there to make your life easier. We will make a whole video series on consecutive sets later. But for now, so if this is even, n plus 1 must be odd, and then n plus 2 must also be even. here, if n is odd, n plus 1 will be even, and n plus 2 will be another odd. So these are my only choices for how my prompt committees can look. Either going to be an even times an odd times an even, or an odd times an even times an odd. So if I start by focusing on my 2's, what is this telling me here if I have this scenario here? So if I have an even here and I have an even here, I am definitely going to have my 2 2's. I'm going to get one from here, one from here. And you actually are going to know you have more than 2 2's, because if you have consecutive even numbers, one of them will be a multiple of 4. So in this scenario here, you actually know you're going to have at least 3 2's, which is more than what we need. And so what about our 3 though? Do we necessarily have our 3? And for that, we'll just start writing out consecutive integers. I'll write out the first 20. So here we have 3 consecutive integers. Do we necessarily know that we're going to have a 3 in there? And you can sort of see where this is going. You can sort of see the rule that I'm about to come up with, where if you have n consecutive integers, one of those numbers always must be a multiple of n. So if you have 4 consecutive integers, one of those numbers must be a multiple of 4. If you have 5 consecutive integers, one of those numbers is a multiple of 5. If you have 100 consecutive integers, one of those numbers is a multiple of 100. In this case, we have 3 consecutive integers. One of those numbers definitely will be a multiple of 3, because if every third number is a multiple of 3, well, then if you just take 3 triplets from anywhere, no matter where you start, you're always going to hit upon one multiple of 3. And so this is actually true. If I have 3 consecutive numbers, I'm going to have a 3, regardless of whether I start with an even number or if I start with an odd number. So that makes the 3 here irrelevant. I always know, no matter what, I'm going to have my 3. So my whole question really now becomes, am I going to have my 2's? And so here, in this scenario where n is even, I know I definitely am going to have my 2's. So this would be sufficient to say yes. But then, before you rephrase your question, you would not want to rephrase your question as just, is n even? Because that is not the only way that you can get your 2 2's. Here, we only have one even number that's in the middle, right? So that means my n and my n plus 2, they are not contributing any 2's. So if I am to get my 2 2's, they all must come from here. So just because this is even, that means that n plus 1 is going to contain at least 1 2. It is still possible that it contains more than 1 2. And so if I were to rephrase this question, I wouldn't rephrase it as, is n even? You have to rephrase it as something like, is n even, or is n plus 1 a multiple of 4? Which would mean it would contain both of the 2's. And this here is a literal rephrase of this prompt. So I'm not thinking about this anymore. I'm not thinking about students or prompt committees or consecutive sets. I just need to know, is n even, or is n plus 1 a multiple of 4? And remember, that's asking me, I don't even care about multiples of 12 anymore, because I already know I'm going to have my 3. So I just need to know, do I have a multiple of 4 in here? So that 3 is irrelevant. So if I start with statement 1 now, statement 1 says n is divisible by 3. And without even having to do any work, you can say this is insufficient, because the 3 is irrelevant. I need to know if I have my 2's. And not only can I eliminate A and D, I'm pretty sure I can eliminate C, because this is not only insufficient, this is irrelevant. I only care about my 2's. This is telling me about my 3's. And all it's really saying is, I already knew that I had my 3's, right? I knew from the prompt that I had my 3. So statement 1 is just telling me where that 3 comes from. It comes from the n. I don't really care where it comes from. So this is not going to be helpful even in combination with any other statement. Statement 2 says n plus 4 is divisible by 2. So I want to know, is n even? This is telling me divisible by 2 just means n plus 4 is even. This, I just want to know even and odd addition rules, which if you don't have that memorized, you can just derive quickly on the spot. So an even plus an even, 4 plus 4 is 8. So even plus an even gives you an even. even plus an odd, 4 plus 3 is 7, gives you an odd plus an odd, a 3 plus 3 is 6, so odd plus odd gives you an even. So in this case, if I have an even, if I'm adding something to an even and it gives me an even, that means n must be even. And because my question is just, is n even, or is it a multiple, or is n plus 1 a multiple of 4, this tells me n is even, therefore B is sufficient to answer this first part of the question. B is the answer.